Buttes, plateaus, mesas, flat-topped geologic features surrounded by steep slopes or sheer cliffs on all four sides are gorgeous to look at and scientifically fascinating. Terms used to describe such features largely describe their difference in size, with the following being from smallest to largest: butte, mesa, and plateau. These features most commonly form due to a hard caprock preventing preferential erosion of a softer rock type which lies below, such as is the case in Utah and Arizona's Monument Valley. Or, they can form due to sediments covering a much harder basement rock which is subsequently uplifted, as is the case with the plateau that contains Venezuela's Angel Falls. These flat features, however, can also be volcanic in origin, deposited due to abundant low-viscosity lavas covering a vast area in a brief geologic timespan which protected softer underlying rock from erosion, as is the case at Canada's Level Mountain volcano. Or, they can form due to a unique glacial interaction magma has after forming a meltwater table during a subglacial eruption such as seen at Canada's Tuya Butte. With all of this in mind, I want to highlight what might be the world's most Suswa's strange mesa, unusual mesa, as it did not form through any of these aforementioned methods. I present this strange 3.8-kilometer or 2.4-mile wide flat-topped island bounded by a series of sheer cliffs up to 300 meters or 984 feet high. This feature at the center of Kenya's presumably still active Suswa volcano seemingly does not make much sense given the context that it both entirely sits inside and rises above a caldera that formed many tens of thousands of years ago. For reference, calderas form due to large volumes of magma being removed from a volcano's magma chamber, either through very large effusive or explosive eruptions, causing the rock overlying the magma chamber to collapse downwards and fill the empty space. This almost always forms somewhat flat-shaped depressions in the ground, such as at Alaska's Aniakchak volcano. However, in the case of the Suswa volcano, there are two key pieces of evidence to determine how its central raised rim formed. For one, it is overlaid by a distinct layer of lava which is the exact same age and composition as those found on the inner caldera floor. Second, while not easy to see on the ground due to how slight this is, the middle island of the Suswa volcano is not a perfectly flat mesa. Instead, it is distinctively tilted down towards the west-southwest at an angle of 1.56 degrees. This equates to a decline of 43.9 meters or 133.1 feet every mile or 1.6 kilometers.